Welcome to another draft physics presentation, mostly. Anyway, I thought I would talk about this particle guru-y thing, this other particle model by David Hilster and Bob, D. Hilster. Anyway, so there should be some sort of conversation about the people of like mind should be able to interact in some sort of constructive way about elements of the theory that are strong and elements that are weak in terms of these different approaches to looking at what a particle model might look like. And I clearly think my model is correct and their model is incorrect. And they may also have the same impression, but we should be willing to test those models against each other and demonstrate weaknesses and strengths in the opposing perspective. And clearly, some of this is in this context of the fact that it is a 300-year-old kind of idea, something Newton considered, and it was dismissed, I think, for the wrong reasons, because it was something that was an actual theory. And I guess that's one of the reasons why it was easy to pick on, is because it actually had a material function where you could test its materiality, where the other explanations sort of had to do with forces being invisible or intangible, like in the Einstein case, an explanation that can't be tested because it doesn't have any residue in the physical universe, doesn't leave any marks. Where obviously a particle model kind of explicitly does leave marks, and therefore it's more easily tested. So the biggest criticism against particle models is this idea of the drag problem. And I've certainly gone over explanations that I think it's a solvable problem. I don't have a 100% solution. I have the pieces of a solution. Now, I haven't even heard Bob take on that challenge, and that's sort of like the biggest one. That's the it's sort of like the ether theorists have to sort of explain why, at least the ether theorists who believe that ether is a substance, that it is something that we can move through, that it would have this drag problem. And so they have to sort of explain why Michelson-Morley isn't a meaningful experiment. And I think that can be done just by pointing out how interferometers aren't doing what they think they are doing. So anyway, I've watched most of Bob's videos, and I have some glaring problems with a lot of the premises, I guess, that underlie it. And one of them is on the subject of levels of the universe, because the theory is basically implying that it's a fractal kind of universe, that there are some sort of similar mechanisms as you go down that function. So like gravity is controlled by some other kind of gravity, and then that gravity is controlled by some other kind of gravity, and that, this kind of thing. And I don't think the evidence indicates that that's a viable way of perceiving things, because the big universe doesn't have any of the qualities that we see in the small universe, especially the magnetic ones or the electric ones, or any of those things are not obvious in any way. Certainly the polarization and all that kind of stuff, the big universe doesn't look like it has any consistent mechanisms or rules that would manifest those little properties in the big universe. The big universe looks really dumb and simple, mostly controlled by gravity, maybe entirely. So let's play some of this, and it's a 21-minute video, so we're probably not going to be able to get through it, but I'll try to jump where appropriate.
The levels of the universe. The question is, what is this about? Is it about multiple universes? About valence levels? Well, sorry, in my opinion, there's only one universe. There are not multiple universes.
Yeah, but the problem with that statement, though, is one universe has levels of universe that could be, in some sense, infinite, and I have a problem with that. So
this is about atoms, but it's not necessarily about valence levels. This is, in fact, addresses the question to only a partial degree about infinity that goes all the way up or all the way down.
So again, this was something I engaged in. I don't know if everybody else would do it, but as a kid, you start thinking about, well, what if you're like this solar system is in the foot of a giant monster in some other universe, and trying to think in terms of Horton here's a Hugh, kind of playing with the idea. But you don't have to play with it very hard, again, to see that there's no evidence of any of the structure that we know is in the small universe, in that the atoms obey very specific geometry. There's very specific kind of energy that moves between electrons and protons, and we know, even though conventional physics doesn't have hard descriptions of what those mechanisms are, we can imagine they would be something visible on our scale. They wouldn't be something as mundane as gravity.
I've often heard the expression, it's turtles all the way down that holds up the Earth. But for now, 4 levels of the universe seems clear, and I'm going to define what I mean by levels. And one more.
So, I might as well go into a little bit of a premise on what his theory involves and some of the pieces of it that I find implausible, I guess is a way to say it. So I'll do some drawing maybe quickly. So he has this thing called a G1 and a G2, and these are levels, you would say. So this idea of a G1 would take the place of both photons and electrons, which doesn't make much sense because photons are doing the constant speed thing and electrons aren't. Electrons are big, relatively speaking. Photons are tiny. There's lots of facts that make it pretty hard to imagine. Yes, you could maybe make an electron out of these things, but they would definitely have different properties when it was made out of something. Say, for example, the speed of light would still have to be in the thing somehow, and it'd have to still have the properties of the particles. So the other problem I have with this theory is that these photons, which we know to be a pretty consistent packet of energy, and you vary it by just varying its frequency. So you could kind of assume that the thing itself doesn't have any identity, and that the real identity is in the frequency or the wavelength. And obviously a radio wave is a lot different than an X-ray, that kind of thing. Obviously a blue photon is different than an X-ray. But we can understand that the difference isn't in so much the structure as we're just talking about the length of it, or as I would put it, the period between them, actually. Well, his diagram of these particles, that he would concede that light's a particle, but he has the photon, as he understands it, is a bunch of photons, and that they come in a grouping, where there'll be a bunch of them and fewer of them and fewer of them, and that would be representing one wavelength. So it would be a whole bunch of these G1 particles would be one thing that we call a photon. Now, it's funny, made a yin yang without trying. And yet they're supposed to somehow be related to or similar to this electron, which isn't supposed to be any kind of there's little distinction made. And to me, they're very distinctively different things with different properties. So I just say, why envision photons as something made of a bunch of constituents when we kind of know that there's no variability in them? You know, blue is blue, red is red, light is a photon is a photon, is a photon is a photon. And the only thing changes is, again, the wavelength. And you can't, you know, if you're going to make it out of 100 or 1,000 or 1,000,000 of these things, it doesn't seem like that's a real complex structure to be able to create something that complex that's that consistent, where each one carries exactly the same amount of energy. It just wouldn't make any sense. So that's just a little preface. Might as well go the step further, which is he would say that these gigantic schools of photons, that is, one photon is a big giant pile of these little particles. He would argue that those photons are being controlled by these G2 things, which travel some unknown mega speed, who knows, you know, some who knows speed, much faster than the speed of light, and that they, like gravity, or like a pushing force or controlling force, are exercising influence on the photons, and that these huge number of photons are somehow being pushed or pulled, well, pushed into their arrangement or into their direction, you know, which way they go, based on this more dense sea of G2 particles that are really invisible and somehow may travel at some speed greater than the speed of light, which means in some ways we should have an indication of their influence, that we should see something happen faster than the speed of light if there was actually a force element in the universe moving faster than the speed of light. It should leave some sort of evidence. And the only evidence is the tiny bits of evidence they have for entanglement. And so it's like, you know, he rejects a lot of conventional physics and their kind of, you know, take a small bit of evidence and turn it into a big giant theory. And yet he accepts what is, in my opinion, some of the most marginal parts of physics, which is entanglement in terms of evidence. So, yeah, so that's my general paraphrase of his theoretical position. Yeah.
Be needed, and that's according to the particle model. But talking about more beyond that gets quite difficult. Okay, so let's talk about the particle model and these levels, and I'm going to define them this way. Each level has a physical center or core around which other objects orbit.
So, I mean, I would argue that the real advantage of the particle model is ending this notion that things orbit or that things do things because of some unknown mechanism. So the whole idea is that the things orbit because there's a force, a pressure, and there's more pressure on one side than there is on the other side, and that forces them to behave. So there's no magical element of force, in the sense that there's no communication or there's no function that isn't require physical communication or contact. A photon travels in a straight line unless it's physically contacted and interacts with something that causes something to change. So all the changes are based on something physical happening, physical mechanisms that are changing where something is in the universe.
So we can come down here to level A, which is our solar system, where the sun is the core. And we're going to move up to level B, where we have a galaxy that has a core, that has objects orbiting.
So I would argue that that's still kind of an unknown, whether there's actually things orbiting galaxies or whether galaxies are just stuff leaving, because it's not obligated to stick around. So yes, there's obviously some force that gives the galaxy a shape and spherical, like the other forces that are pushing things together. But the other thing it doesn't have in common with other things is the fact that it is very flat. So it's very unlike a round sphere planet or a round sun. Those things are being created by gravity. But the flatness of even the solar system, it's pretty flat. That has a different explanation in terms of an explanation of what exactly the mechanism that caused it to be in that condition. And those are sort of important causes. Well, I mean, what creates it, the mechanism that creates it.
Then we go to level C, and I've looked about, and does not appear to be any central core for any of these things they call groups, clusters, or superclusters. They do seem to hang together in groups. And what
So again, we don't know whether they're hanging together or they're actually falling apart. We don't know whether they're getting smaller or bigger. So all of that is unanswered questions. But again, there's no real similarity between these different things besides the force, which is gravity. So besides the commonality of gravity, there's nothing common necessarily in why they exist in that form, how they were created. Where we know, like, our own solar system was created out of dirt from other supernovas and that kind of stuff, that it's dust coalesced. But do we know that's the answer for galaxies? Or is it maybe the opposite answer? That everything consolidated, and the consolidation was under too high a pressure, and it unconsolidated in a little mini bang.
Gravity is probably what causes that, but there's no sense of orbiting. Maybe there is, or maybe there isn't. Level 1 starts the way down, starting with atoms. Atoms have a nucleus, that's the core. Subatomic atoms...
So again, the fact that there's something in common doesn't mean there's anything in common in terms of the structure. So it's sort of been demonstrated that you can't use like regular gravity to explain the bonds between electrons and protons inside of atoms. We know that that force is magnetic, that it's a stronger force, it's not as unfiltered. It's filtered force. It's not raw. However you want to understand the difference. It's like the difference between a stick that's got a dull end and a pointy end. It works differently when it has a pointy end, and the forces are different when they're filtered. And I would argue that magnetism is the same force as gravity. It's just being filtered for the polarization. And this is another thing he doesn't, in his particle model, the idea of charge isn't a significant manifestation. And in mine, it's everything. It's the fact that there are two different elements that can be filtered means that there are consequentially a lot more ways they can interact with each other. The whole black and white thing, the whole idea that something's attracting and then something's repelling because of the way you interact with it. Oil and water. And as soon as you have oil and water in the universe, when it's mixed, it's one thing, and when you can separate the oil from the water, it's something else.
They exist, also need to be a core, and we'll talk about that. Is there a level 3? Particle model at least suggested, but there is no evidence.
I don't really go for the particle model as if he has the only particle model, and that particle models have all this in common and all this, this is the argument. I mean, it's a little bit too pretentious to say you have the particle model, in my opinion.
So you start at level A, and there's the solar system. Yeah, we're all familiar with that, and it has the sun as its core, and then the planets and other objects orbiting around it. Level B is a galaxy, and it has a core, and with all the things that we can see orbiting around the galaxy, you
So again, the idea of whether it's being collected or whether it's being spewed is, I think, an open question. You know, I would tend to argue that why wouldn't it be becoming spherical if it was the internal force that was pulling it together? You know, there has to be a reason why the material tends to be on a plane, you know, and for something that size with the amount of gravity it should have, why is it that way? Why is everything on that plane? How does the dust first move to the plane before it moves in? And it just seems more sensible to say, well, it's more likely that there's a reason why it's spewed on the plane. It spreads on the plane. It gets fat on the equator. And if say if the Earth was to disintegrate because of its rotation and its fact that it's a little fat at the middle, it would tend to spread from the middle out, just because it has a bias in that direction. And that seems to me to be evidence of reason to believe that galaxies are shaped the way they're shaped because of an expansion, not a contraction. Now with the solar system it's a little different because the objects themselves are massive, you know, the planets, and they have consolidated anything that would have been in the orbital arrangement, and they've essentially cleaned all the dirt, and then they align because gravity is going to tend to align them over time. Their mutual gravity.
Imagine there are more stars in there, and so things, the solar systems can exist inside the galaxy. That's level B. Level C, they have local galactic groups. Apparently there's 2 galaxies here. I'm not going to go into detail there, but they look around the skies and they see some of these things in smaller groups. Here's the Virgo supercluster.
Yeah, well, we've never really seen anything called a randomization. You know, what would you expect out of a random mixture where, you know, you're always going to have clumps that are hotter or colder, or more of them collected and less of them collect, and there's always going to be reasons why that would happen. It's not going to be perfectly homogeneous. Everything is not going to be 5 feet from each other. There's going to be some stuff that's closer than 5 feet and some stuff that's further than 5 feet. And what are the odds by just random? What would the odds be? And how long would it take for something to be, a system to become homogeneous? If you start off with an explosion in a cardboard, in a box, and the explosion the energy had to just bounce inside the box, how long would it take for all the energy to be evenly distributed?
This is actually the Virgo sign, although seems to be upside down from the sign, but nonetheless there's the Virgo supercluster, and it has multiple galaxies in it. So anyway, and I'm not discussing level C because I have no information to talk about. So we'll start in a little bit more detail about level A, the solar system. The objects in the solar system are the sun, planets, moon, comets, asteroids, whatever else, and it's gravity, G1 gravity, that keeps these objects in orbit around the sun. And all the objects are made from atoms from level 1 and below. The mass of the solar system is measured using G1 gravity in units of kilograms, being compared to the kilogram standard. The only way we have a value for the mass of our solar system, or the individual objects in it, the sun and moons and comets, is because we have a standard to compare it to. We measure the motion of an object against the motion of the standard, and we can assign it more or less a value.
Yeah, well, that gets a little bit, obviously, because you're using a standard that's based on the effects of gravity. So you're just saying this substance is affected by gravity. Now, you don't know what's inside the substance, in the sense that what part of atoms actually are carrying what might be called the atomic weight. So you don't really know whether the electrons are the thing gravity's pulling or the protons. Because regardless, whatever one it pulls, it's going to affect the others, because we know there's forces between them. So it's still kind of a vagary as to what exactly gravity, what is sensitive to the force of gravity, which I would argue with you is made of bits of energy like photons.
So we can measure the solar system and give it units of a kilogram, because the G1 standard is based on the kilogram is based on the G1 standard. The speed of the solar system, the particle field that keeps the speed of these objects to less than the speed of light due to drag. All of these objects, from level A up, are...
Okay, so you say keeps them below the speed of light by drag, but then you have to account for drag if you say drag exists. So then you'd have to explain how light gets across the universe without being dragged down, and certainly why some other mechanisms can be shot into space and keep traveling without slowing down. So clearly they're not dragging.
Subject to drag. I mentioned drag in the video that I had earlier called Faster Than Light versus Drag. And it turns out that when you have atoms with nucleons in it, these objects are not going to move faster than light, because the faster they go, the less push G1 gravity gives them.
So I don't see how that can work at all in terms of arguing that you can have a field of pressure and you don't have to somehow account for how something can move through that field without creating more pressure. That the movement of the object towards you is somehow different than your movement towards it. And there really can't be a difference. So you have to explain why on some subatomic level those interactions aren't significant. No, I don't think he did that.
And the more push back that it gives them, and the force to accelerate them slows down. The speed of the stars, for example, at the edge of the galaxy can be as high as 280 kilometers per second. What I didn't give was the speed of the planet as it moves.
Right, so this is more stuff where I would argue that there's a lot of conventional physics that you seem suspect of, you don't trust as truth, and yet somehow you do trust the approximations of how fast things are moving in 13 billion light years from here, based on just redshift assumptions. And that might not be a reliable way of detecting speed. I mean, real velocity.
Moves around the galaxy, but nonetheless, the speed of the planets and the star and around the galaxy is around 280 kilometers per second. Okay, so in the galaxy, the objects are the core. You have solar systems and stars in the galaxy. The mass of our galaxy is estimated to be at 5.8 times 10 to the 11 solar masses. That is, you take the mass of the sun, multiply it by 5 times 10 to the 11th, and you get the mass. I presume this is the visible mass.
Right, and it's not a mass that's evenly distributed in a sphere, so it's not like you can calculate the same way you would calculate like the sun's gravitational effect. So clearly by a particle model, the gravity is on a plane, and because the mass is on that plane. And from other locations where you would typically around something have gravity that was very strong, the gravity around a galaxy that's facing you this way is going to be very different than the gravity facing you this way, because there's more mass density for that vector.
Not dark matter. In fact, I think when you add dark matter, you get numbers like 10 to the 42nd kilograms. Anyway, the speeds are comparable. This is the speed of the galaxy itself, 631 kilometers per second. The higher you go, the slower it is, the greater the mass.
So I don't think this really deals with the problem of calculating velocities that way, where if two things leave a location at right angles to each other, they create the illusion of distance. You know, I mean, it's really happening. The distance is real, but they didn't travel enough distance to create the distance. So it's, in a sense, it's perceptual distance, but is it real distance in the sense that they haven't moved it overtly away from each other? So it's not like they have a speed this way. They don't really have a speed this way, if I can say it that way. The fact that they're going in different directions doesn't mean they traveled the total distance difference between them, and we might be overestimating their speed because we're measuring the product distance rather than the elements of velocity that created the distance.
One would guess that if you're going to go infinitely up, that by the time you get all the way up, things are so large and so they're not moving at all.
Well, that's another reason not to jump on this bandwagon that it's fractal-like, because we don't see suns that get really huge. We don't see a lot of mechanisms that have some sort of infinite capacity to just keep getting bigger and bigger. We see that for a certain configuration there's a limit, like how big a terrestrial animal can get, how big its legs can, how long they can get, how there's certain rules, and you can't go past those rules, and then the thing breaks down, the system breaks down. So they're all systems depending on a very specific, subtle mechanism, and it's really not applicable to sit there and play this. You know, the Hubies are just like people, except they're really tiny. Kind of doesn't work that way. Viruses aren't little people. You know, they're a different kind of structure, a very simple kind of structure.
Would be my guess, but what information? We don't have any information. I stop at level B. Level C, I'm not even describing. Starting at level 1, going down, the objects included here are atoms that are in our periodic table, made from nucleons and G1 particles. I've been saying that over and over again because
right, and it doesn't fit with 200 years of science. So I don't know why nucleons and G1 particles. We know there's protons and electrons, and that there's charge inside of atoms, and neutrons, and we have whole specific arrangements of those particles that create different ability for atoms to stick to each other for real specific reasons of those things being in the right positions. So I just don't understand how you can rewrite that whole part of physics and just pretend electrons aren't real things and protons aren't real things. I think science has done okay to identify those basic structures as being elements of function. Now, whether there's quirks and all this other crap, that's subject to debate, in my opinion. But I don't think you can argue against electrons and protons. And there's no evidence of a nucleon, whatever that is.
Level 2 that we're talking about, and now starting to talk about the nucleon as being an N1 particle. And gravity 2, G2 gravity, keeps the G1 particles in orbit around the N1. So the G2 gravity is the nuclear binding force.
Right, so he has a thing that's as small to a photon as, you know, gravity to the sun or something. I don't even know how to make these comparisons, but this much tinier thing is somehow controlling these very tiny things that we can't even see. You know, and those tiny things are somehow controlling the big things that we can see. And I think I don't think there's anything called evidence of that, and I think it creates all kinds of paradoxes regarding how fast you're going to make these little things move, because you're going to end up making them move faster than the speed of light. And if they are doing that, then you're going to see influences in the universe that are going to reflect that speed. It's going to leave a mark somewhere, and the mark is going to have this indication that somehow you can go faster than the speed of light, that information travels that fast, because it would be information. There's no way, if it can affect photons, then it's information.
Molecular binding force that keeps things together, keeps the G1 in orbit around the nucleus. The mass of the atom is in kilograms. You can measure the atom in kilograms.
Yes, you can use gravity and create a scale and measure how much affect the material, how it's affected by gravity. But that's all you're really doing, is you're just measuring how many elements it has inside of it, what percentage of its density is made out of these bits that are affected by gravity. But that's all you're really measuring. You're not necessarily measuring its entire structure as the parts that may not be affected. The parts that are attached for other force reasons. Probably not the right way to say it. Continue.
Let me counter that with the fact that the mass of N1 and G1 cannot be measured in kilograms. The interaction is different. When you use the standard kilogram object as a comparison, it's made of
I think the easy way to explain that would be just to say the G1 particles obviously can't be measured because they're the things creating the effect on the scale. So you obviously can't measure how they're being affected by a force when they're themselves the force. So obviously if I shoot a photon at the scale, the photon will register an impact, but it won't because of some gravity. You're not measuring its gravitational significance. You're measuring the fact that it's a force element. It's a piece of gravity, essentially. You're measuring it as force. You're not measuring it as something affected by force. And so I think as soon as you create a field that's moving the photons the same way that planets are moved, I think you're in big trouble.
Platinum and iridium, these are atoms that have open space, and the G1 gravity passes through that object and on occasion interacts with it. But in the case of the N1 and the G1 gravity cannot pass through a G1 particle. A G1 cannot pass through a G1, and in fact it can't pass through.
Well, it obviously does, though, so that's the catch of what you're saying here, is obviously light doesn't bounce off of light. Photons don't bounce off of photons. So all the forces don't interact with each other. You can't deflect light with a magnet. You can't stop the photons from moving the speed of light with a magnet. You can't use these forces to stop other forces. So clearly the force bits don't interact with the force bits.
An N1, it can't go pass through an N1 because light, which is made up of a stream of G1 particles, when it hits a mirror, reflects off of the mirror, primarily reflecting off of the N1 particle. If it went on through the...
So he's saying it's reflecting off the nucleus, and I don't know if that's I don't know if that's accurate. When clearly we know there's such a relationship between the electrons and the photon type forces. The electromagnetic spectrum is substantially something that affects electrons. So when I was saying the forces don't interact with forces, by interact I mean they can't change anything. So they clearly could interact in the sense that the rule could just be as if they hit head on. It doesn't really matter if they do this or if they go right through each other. I mean, you can't tell the difference between the head-on collision and the miss. The end result will be the same. One thing going this way, one thing going that way, and it won't change anything. So they could interact, but they only interact in this way. They don't interact at angles. So you can't shoot a photon and then hit it with a photon going this way, and one ends up going this way and one ends up going, well, it still would end up the same thing. If it's a 45-degree angle, you get two things leaving at a 45-degree angle. I'm just saying the interactions are so simple that if you don't have something like polarization to follow where something's changing, like this red one changes, well, if that's not happening and it's all black, misses look just like hits. So maybe the G1 particles do interact with each other, but they only interact in this completely kinetic way, which means when they hit, one thing takes the direction of the other, and you just end up with the same condition you started with. So I don't mean to imply they don't interact. I'm just arguing that their interactions are moot. They can't have any significance unless you understand that they have a difference in identity, and that identity changes, in the sense that the red that was going this way ends up going the way the black was going, and vice versa. And now you have a change that you can see.
Be no reflection. So the mass of the atom can be measured in kilograms. I'm not sure they actually do it, but you could at least say, okay, here's the helium atom and here's its mass in kilograms. You can't use kilograms for N1 and G1. You have to have a new standard. A lot of work, a lot of thinking about how to even do that. The speed
I don't think you have to, because I think we know they are affected by this force, interactions with force. So you just measure what force they're interacting in, and you can measure. Obviously, an electron has more mass, okay, when you're interacting with a magnet. Obviously, there's the gravity, or whatever the force would be that would move the electron, is changed by the presence of the polarized field. So I don't think you need a new standard. You always just have to always be aware of the fact that things move based on what's hitting them. And if it's a black bit or a red bit, then there's a difference.
The atoms are limited by the drag, not the frag, of the G1 particle field. As I've said before, N1 particles have been accelerated, for example, close to the speed of light. In linear accelerators, they get them to move quite fast.
Right, but there's no evidence that they are N1s or nucleoids or whatever you're calling them. There's no evidence that they ever took one to almost the speed of light and then slowed it back down and had a whole nucleus left, a proton or a neutron. There's no evidence that they've accelerated these things, and that the process of accelerating just didn't break them into their constituent bits, their quanta, and that their quanta was moving the speed of light, which would be they were essentially converted into energy. They were converted into light through the process of acceleration. The matter was disintegrated, and all you had left over was the radiation, the gamma.
Fast. So they can move fast, but in general, the N1 in nature doesn't move that fast. I mentioned 280 kilometers per second. The G1 particles have an orbital speed that is at or about the speed of light. And that's how we get the speed. They're built that way originally. Why they're built that way and why it's this way, that's a philosophical question.
Well, I don't know if it's entirely a philosophical question, but I think, again, your theory doesn't make enough of a distinction between the G1 particles in the form of a photon and the G1 particles in the form of an electron. And I think you have to account for the fact that one is clearly a material player. It's a player in terms of it being matter-like, and the other is force-like. And they're really different forms. To say they're the same thing is just too casual.
It's left for another discussion. Now let's talk a little bit about the structure of the N1 nucleon and the G1 particle. The requirements for the N1 is that for G2 gravity to hold the G1 in orbit around the N1, there must be open space in the N1 and G1 for the G2 to pass through.
All right, so now he's making the metaphor where particle models of gravity are dependent on this idea that every single bit inside of the material is in some sense exposed to the force, which means the force has to have access to, there has to be a huge density of it traveling through something, and that only a certain percentage of the force is consumed or absorbed in terms of actually hitting something and moving it. But it's only a percentage of the force, not the entirety of the force. So it's not like it bounces off the surface. It's an absorption. It has to travel through, and it has to be absorbed. A certain percentage of the force is absorbed. That creates the shadow. So it's about, having a high pressure on one side, having the object absorb that pressure and move into the low pressure because it's absorbed energy going this way, and there's less energy coming this way because the other object has been shielded from energy and is now moving towards it, which means it's consuming pressure. And by consuming pressure, they create this low pressure between them. Now he's taken that model and moved that to the scale of the atom, which, in my opinion, is kind of wrong from the start, because we know what's holding atoms together is something different than gravity. It doesn't work the same way because it's not nearly, gravity wouldn't create enough energy to control things moving as fast as what they think is happening inside of atoms. Now, I don't think atoms are doing this orbiting stuff and all that other crap. I don't think any of that's happening anyway. But then you have to have magnetism to keep things in their position. And it is clearly magnetism that's doing it. So you should be explaining how G1 creates magnetism once you start talking about atoms. And it's not really a gravitational force, it's a magnetic force. And then you're back to polarization, and you don't have any accounting for that.
And secondly, the G2 particle must be faster and smaller than the G1. It has to be faster in order to cause light to bend, light to change speed or direction. It can't be doing that if it's moving.
Right. Well, we argue that you can't change its speed, so that's sort of a misstatement. So all it can do is change its direction, and you think that's possible because there's a few experiments that indicate that that's what happens. But those experiments, in my opinion, can be more sensibly explained as photons hitting something material, like electrons, and that the electrons are changing the path of the photon when they're re-emitted. So I think there's more viable, more rational explanations than photons are in a pressure field and they're being manipulated by pressure, because there's really no indication of it. And they don't display any of the effects of magnetism, which are, things that are magnetic don't really bounce off of each other. They don't hit each other. They bounce off the force between them. And so those kind of reactions are much more subtle than the head-on kind of reactions. So their reactions aren't kinetic in the sense that they're pressure dependent. And so speed becomes important, how fast you're hitting the force, how fast you're interacting, and how direct the interaction is, has a whole scale of variance in the possible permutations, where what you see in photons appears to be much more angle in, angle out. There's no variances. It's all really rigid geometry, not the kind of geometry you get from magnets bouncing off each other.
That's speed c or slower. It has to be smaller than the N1 and the G1 in order to pass through it. That's a requirement of a particle model gravity.
Well, your model of gravity. And again, well, obviously it has to be smaller. I mean, we imagine gravitational particles being insanely small compared to like the planet Earth. They're small, like the size of photons, tiny, tiny, tiny things. You're saying you're moving this tiny photon thing with another force that is on the same scale of tininess. It wouldn't be some kind of force that's the same size as a photon. So, and you're talking about minuscule changes, so you'd have to be a tiny, tiny little thing.
And at this level, the N1 and G1 must have open space. So let's look at three different options. Quantum mechanics, I'm talking about the structure of these atoms. The three options. Quantum mechanics has their idea. For example, the proton is made up of two up quarks and one down quark. And the neutron is made up of one up quark and one up quark and two down quarks. Just the opposite.
Okay, let's just say, for example, that this was true, or that it, that we could sit there and dissect protons and electrons. There's absolutely no circumstance in most 99% of all physics, 99.9999% of all the physics and all the chemistry and all the rest of it, where it's ever relevant to have a conversation about what's a proton made out of. What's it made out of never even becomes important. Protons don't just spontaneously degrade. They don't just fall apart. These are really reliable pieces of crap. I mean, you have atoms inside of you right now that were inside of people 300 years ago, 500 years ago, 50,000 years ago, a million years ago. Those atoms have the same electrons and protons inside of them. I mean, these are really reliable little pieces. Why worry about what they're made out of? The real question is, how do they function? And so this whole conversation about what a proton is made out of, I think it is so distant from explanations about why they behave the way they do. I don't think it's at all necessary to dissect a proton to understand it has a charge, that it plays a role in an atom that's very specific and seems to be connected more intimately with neutrons, and therefore creates what might be considered a center to an atom. And those are premises that are pretty solid, versus extrapolating into a bunch of speculation about how their intimate structure has something to do with any of that, when you don't really need a diagram of their guts. It's a car, and and the important thing is understanding how cars work. Not understanding that it's made of rubber wheels and all that stuff is kind of unimportant to the race. It's understanding the race.
The opposite. And in quantum mechanics, the electron has no structure, it has no parts, it's a solid piece, a particle. This one is basically rejected based on the fact that the proton and the electron have positive and negative charge, and I have no information from anywhere that describes the physical property that gives the proton a positive charge.
Yeah, I know, but the fact that it exists as a phenomenon is lots of evidence for that. Okay, so the fact that there's repulsion and attraction, and that there's rules of repulsion and attraction, those facts are really solid. So to pretend that we don't think it's part of the structure of the electron, like the electron has a structure that's fundamentally different than the proton in some key way. I mean, all it means is a switch is on or a switch is off. I mean, they be identical in some kind of respects, but we kind of know their masses aren't quite identical. But regardless, their charges, in terms of its potency, what was a better way to say that? In terms of how it reacts in the field. The field treats them the same way.
It gives the electron a negative charge. Just because you write plus and minus on it doesn't make it a charge and doesn't cause it to move together.
And again, that wasn't why they drew plus and minus on it. They drew plus and minus because they behaved in very specifically opposite different ways. So again, it's just to deny the existence of the phenomenon of magnetic attraction and repulsion, and that magnetism is, fundamentally the cause of electricity. I just don't know where I don't know why you do that. That seems like something you want to explain, not something you want to dismiss.
You need to have a physical property that causes them to move together, and I don't see that. So I'm not accepting that as the structure of N1G1. Or you could have a number 2, a rigid particle with open space. Somehow it's just built that way. That's an option.
Yeah, I don't mean to imply that I don't think that the fundamental nature of the universe is that there's some sort of unique, there's some quanta particle, and that everything's made out of those things in different arrangements. So, but there's clearly something very obviously different between two magnets turn this way and two magnets turn this way. I mean, there's a certain fact that in the nature of the universe there may have to be some fundamental difference that creates all the other differences. A universe of all one thing that does just one thing would be a universe that couldn't get complicated.
It doesn't, in the particle model, it doesn't help solve another problem. So the third one I'm suggesting is that there are subatomic atoms. And as in atoms, at any level.
So this is like way off the reservation sort of point where you just say, what do you mean? I mean, there's subatomic atoms. I mean, atoms inside of atoms now. What do we need those for? I mean, you have the basic elements, of attraction and repulsion. So you have all the elements you need to describe the function of an atom. You don't need to create more elements. You don't need some other mechanism. So to put little mini atoms like mitochondria or something inside the atom, it just doesn't need them. It doesn't need more nucleuses and more mitochondrias or more energy cells or more mechanisms. It already has enough mechanisms.
Or something, if you want to call it whatever or a system that has objects orbiting creates space. There's space in a galaxy. There's space in the solar system. There's space in a regular level 1 atom. Subatomic atoms provide open space since they have orbitals if the N1 and G1 particle are made from subatomic atoms then it satisfies this requirement that they must have open space.
Well, I don't know if there's any requirement that they have anything but certain simple and consistent rules regarding interactions. So the idea that two photons couldn't possibly clump together, or things couldn't be clumped in such a way as nothing travels through them, they have to interact with the surface. I don't think there's any rule against it.
And it does. And the second thing is, so it provides the open space, and if the G2 particle is the orbital of the level 2 atom, it will be small, and it will be fast, and generally faster than the speed of light.
Yeah, and yet there's no evidence in all of physics, really, any hard, reliable, good evidence that anything ever travels faster than the speed of light. So, you know, why speculate about the existence of something for which there's no evidence? That sounds like what conventional physics does. It just makes up dark energy or makes up some other solution to a problem that's completely inconsistent with anything called real evidence.
So these particles would exist and inside the structure of the N1 and G1 if the N1 and G1 were made from subatomic atoms. Level 2, talking about subatomic atoms, maybe there's a whole family of atoms. Maybe there's not just one atom. Just like we have a periodic table, you could have A1, you could call the atoms in the level 1 the A1 atoms, and level 2 A2 atoms.
Yeah, whatever. I just don't even know why. What is the role these things are playing that you need to create them for? Why are you putting hoobies inside of the atom? What do we need them for? What's their role?
That's really stretching it. But it has to have a nucleus, so I call it the N2 particle. That's the nucleus of the subatomic atom, and it has an orbital, the G2 particle. None of these are...
Yeah, so I just don't even understand any of this at all. So these atoms would be like we are, like, you know, the Earth is to an apple what an atom is to an apple, and then the atom is to the, you know, whatever this is, the subatom. I mean, it's just, where are you going with this? I mean, it's even hard to imagine that you would take the force elements you call G1 particles, even making atoms out of them, so to speak, seems fetched, you know, in the sense that you're saying that electrons are somehow these particles. But the evidence is that electrons are something else. They can be made out of them, but they're something else. They don't behave like them.
Objects exist in standard physics. They're just not there described in this way. They have their particles, but they're not described this way. There is no evidence for the level 2 atom nor the level 2 nucleon. That's no evidence for this or this. However, the G2, I determined using refraction that there might be a G2 particle causing refraction because it looked like there was a force of gravity around the prism causing light to bend. And since I'm generally
yeah, well, like I said, I don't see how yes, you can say that, but how you make a mathematical model or, you know, some sort of dynamic where that becomes practical, that somehow prisms know how to do it but some other object doesn't know how to do it, then all of a sudden your gravity is now specific to something that's transparent to light, something that's not transparent to light. Why would they behave so differently? Why would the reflections be so different? So, you know, you're just kind of ignoring the fact that the difference is in some sort of gravity, the difference is in the molecular structure of the thing the light is hitting.
Have an opinion that things are made of particles and that gravity, Newtonian gravity was a particle. I immediately assumed that there was a gravity particle for light, bending of light, and talked about the G2 particle and then hence the G1.
Right, so that's just the Horton hears a who kind of thing. Because this thing works this way, we're just going to assume everything has a common function or something, and we're just going to ignore the fact that we're handed a pretty clear illustration that polarization is really important. That charge is really important.
There is an interesting point to be made, and I'll be showing this in another video whenever I get to it. But in some cases, as in diodes and transistors, the G2 force field inside these components behave very much like an electric field. That may not be the only case. So the force field that you see described, you read it in the literature, and it says there's a electric force field inside the transistor causing the electrons to move in a certain way or not move, depending on the voltage, for example.
Well, I don't think the word force field is very useful when you're trying to make understood that all the forces are basically some sort of real physical particle thing. So it's not a field of force, it's a field of energy. It's a field of photons, and that's why conventional science calls them virtual photons, but it can be understood that they're just a variety of these little bits that move the speed of light that affect electrons and protons.
On the base of a transistor or the voltage across the diode. They look very similar. Maybe there is a correlation between the G2 and existing evidence.
I would argue that the thing you should have caught on, grabbed hold of, and said, yes, this is a good starting point, is all the forces have the same speed. So the fact that all the forces move at the speed of light, that's the giveaway. That yes, of course, they're all the same thing. They're just different manifestations of exactly the same mechanism, the same bits.
Of an electric field, but we don't have an electric field in the G2 in the particle model. We have G2 gravity.
Your particle model.
In summary, the G2 particle is needed to cause the G1 particle to change direction and speed as in refraction. The G2 needs to be faster.
Right, so this idea that you need another gravity to move the gravity, and then you need another gravity to move that gravity, and then you need another gravity to move that gravity. No. No, I don't think you do need any of that.
Than the G1 in order to catch up to it and even interact with it. The G2 needs to...
I don't think photons are ever interacted with. They interact. They move electrons, and when they do that, the electrons change where the photon's going to end up going, and that's it. But there's no other way to change a photon's direction. It has to hit an electron or a proton. Has to. Has to interact with one of those two things, or nothing happens. It just keeps going in a straight line.
Be smaller than the N1 and the G1 in order to pass through and interact such that there can be a gravity type interaction, and hence the N1 and the G1 need to have open space. It's the subatomic atom.
Again, the open space thing is just obviously when you break something down and it's going to have little bits inside of it that are interacting and creates veins and arteries inside of us. You have to have separation between different mechanisms and all that kind of stuff. But the idea that there's some kind of law that says there can't be something solid and there can't be some other thing solid, and the solid thing hits the solid thing, I don't see any rule against that being at some level how the machine works. That it's just a kinetic reaction on checkerboard. It's a checkerboard. The checkers move in a mechanical way.
That provides all of these characteristics if the N1 and the G1 particles are made from subatomic atoms that satisfy the criteria. That's in summary, that's where the G1 particle comes from. So we have these levels. And this is an arbitrary distinction of that.
Yeah, it's incredibly arbitrary. A, B, C, and 1, 2, 3. I don't, if you're going to bother scaling it, then you might as well just start with let's just assume a 0 at our level, and we'll go negative and positive. But yeah, I don't know. Whatever. Number 3, maybe.
Levels based on these having a core around which objects exist, an orbital system. You could go all the way up, and you got.
So I would argue that the evidence that orbital system is the right way to describe what's happening inside of an atom, I guess I would just say that that's kind of archaic, and I think they've clung to it still. I mean, they still have electrons doing this, vague space thing, and they're in vague orbitals in these vague locations. I think it's probably they're in very specific locations, and they just jiggle, and that's it. They move this way and that way, and they do this, and we're confusing that with something much more elaborate, because Brownian motion and everything else, we can't see the damn things, so there's assumptions built in.
A and B seems okay. C may have orbitals. It's not clear to me. The further up you go, if you believe infinity up, the greater these objects, the larger the mass, and they're in kilograms. And to my mind, the slower they go. And if you ever really
right, so if you're going to play that game of saying it's open-ended, then you have to explain why it wasn't open-ended for suns. Why can't suns get a billion suns stuck together, or a zillion suns, or quazillion suns? Why, if the system is made that way, where it's all built out of one thing, or one repeated pattern, why do we see obvious limitations in the universe that exists? There's obvious rules that say you can't get bigger, can't do the same thing anymore. You have to do something different.
To infinity, it would seem like they're stopped. They're not moving. The move on the way, going lower, starting with the atom and going down. There seems to be obviously good evidence for the level 1. You could argue that subatomic atoms, that's pretty speculative, but I maintain that if there were subatomic atoms, it needs a nucleus, it needs the N2 part.
Yeah, I know, but isn't all that just more conversation that seems to be a distraction from what the fundamental purpose is, which is to identify the simple rules governing the simple effects? The stuff, like whether electrons are hurling around protons and neutrons, or, what exactly is making for the chemistry's attachments, and, these basic rule mechanisms, quantum mechanics. Do photons break into wave packets and travel in 2 directions and then recombine into a photon again? All that kind of crap. Isn't that the more important question than speculating about, dark matter? Or, isn't conventional physics guilty of this very thing of let's just speculate as if it were true, and let's pretend there's multiverses, and let's do this and let's do that, and maybe our math will work better, and because we can throw all our error code under the multiverse rug. It just seems, is that really purposeful? Is there really any point in talking about something you're just making up and saying, well, let's imagine that there are hoobies in dust balls? Is that really constructive?
Particle, and that's where the G2 particle comes from, that is moving faster than light. G3, maybe there's a G3 particle that keeps the subatomic atoms level going, and you could make a better argument going all the way down at infinity. But in this case, the particle gets smaller and smaller and smaller and smaller.
Yeah, well, you've already got it going insanely faster and faster and faster, which is a huge problem, because again, that would require footprints to be left behind somewhere, and there'd be evidence of this effect of the fact that I could create a mechanism that creates lots of G2 particles, and that lots of G2 particles go somewhere and create a G1 effect somewhere else, and they do it in this instantaneous manner, or what seems like instantaneous. So again, it's not a practical, I don't think, a practically viable foundation to build on.
It has to go faster and faster and faster and faster, and I don't know what you get at the bottom. Being an engineer, I'm happy with levels A and B, and I'm happy with level 1, and reasonably happy with level 2.
Which level 2 is subatomic atoms. Whatever that means.
Not going to even go into level 3. My name is Bobby Hilster, and I am your particle model guru.
Yeah, well, I don't really like you claiming to be, I'm king of the particle models. There, should I say that? I'm king of particle model. Well, you know, your grand poobah of particle model. I mean, whatever. I mean, I guess if you were fully informed on all of the other particle models that might exist and their strengths and weaknesses, maybe you could be called a guru then. But it seems to me that all you know is your model, and that's the beginning and end of your guru-ness, which, you know, it's your prerogative, I'm just saying. I don't like it much, personally. But anyway, until next time and such. Yeah, I don't know if there's anything to. Everything needs to be thoughtfully examined. I mean, all the conclusions of regular physics are, in my opinion, suspect, because they really haven't used Newton's caution. They've really jumped the evidence, as I've stated, and then they've confirmed their evidence by looking backwards and say, well, it couldn't be true, or we couldn't have gotten here from there if that wasn't a stair. But they jumped over the stair. They didn't step on the stair and walk up the staircase. They're cheating the whole process. And they keep saying, I couldn't have climbed this high up the staircase if all the crap below me wasn't bullshit. Well, of course you could, because you jumped over it all. You know. But anyway, it just seems like all models tend to want to do that, and they all should be required to do this process of explaining how it all fits together somehow, and that it doesn't create a whole bunch of paradoxes and a whole bunch of questions like, what? You know, where did that come from? Dark matter. You just invent it? Oh, it's the invisible man that comes to the rescue and saves the day. Alright, anyway. Till next time and such. Long video, sorry. Wait, sorry. They come out that way. It's not entirely my fault.